Good morning, everybody. Can you hear me?
Yep.
Good.
Yes. Cool. Okay, so let's start our second lecture. So today we're going to dive into two-dimensional, incompressible, inviscid aerodynamics. Just as we said in the last class, we are making three major assumptions. Inviscid, basically assuming the fluid does not have any viscosity or the viscous force is negligible. This is appropriate if we have, essentially if the boundary layer is very thin and we can neglect the viscous effect in everywhere except for a very, very thin layer near the surface. Incompressible. This is the assumption that our velocity is much less than the speed of sound, so that the pressure field can really respond instantaneously, because the pressure field they propagate at the speed of sound, right? So if you assume the airplane flies at much lower speed than the speed of sound, then we can basically assume pressure propagates infinitely fast. And the consequence of that is going to be analyzed in this lecture. We're also assuming everything is two dimensions, so we don't consider three-dimensional effects yet. This is appropriate if we are looking at a very slender wing and we're looking at the middle section away from major geometry changes along the span. And a goal of this section is really to try to explain not only qualitatively but also quantitatively the pressure distribution on wings and airfoils, and thereby explain the lift and be able to predict how much lift we are producing on aerodynamic surfaces.